Good evening, everybody. Thank you so much, Gary, for that very kind introduction. I will try to do it justice. And good evening also to all the listeners who are out there on the internet listening to this remotely. So, fixing a broken food system, I'd like to offer some ideas. It's a very complex and difficult topic, and so these are just some ideas that could contribute. I want to start by something that I'm sure you already know about. There has been this tremendous increase in food production since 1960. This is really the triumph of our modern agricultural system, that we've nearly tripled food production since 1960, much outstripping population growth that happened at the same time. And for that reason, we actually have much more food produced per capita. In fact, we're awash in calories in a way. We produce 4,600 kilocalories per capita per year, per day. I'm sorry, and that is far more, of course, than any one person would need to eat. But at the same time, this paradox: we have about 1 billion people that are chronically hungry, and we also have another 1 billion, the hidden hunger. So 2 billion in total with micronutrient deficiencies. And on top of that, we have a growing problem with obesity. 800 million people globally obese. Often such people are also micronutrient deficient because it is too many calories but of the wrong kind. And so, as Amartya Sen famously said, starvation is the characteristic of some people not having enough food to eat. It is not the characteristic of there being not enough food to eat. While the latter can be a cause of the former, it is but one of many possible causes. So we are producing so much food, it is not being distributed to those in need of that food. And our food system is failing us in this way, but also in many other ways. And as I'm sure you've also learned in this course up until now, modern agriculture is fundamentally unsustainable from an environmental perspective. One of the issues is soil erosion and the loss of agricultural lands, of arable lands. With our modern farming systems, we are eroding soils far faster than we can generate them. And this is a fundamental issue of sustainability. We cannot have agriculture without protecting our soils. We use 70% of fresh water supplies for agriculture. We're at capacity in using that water, and yet our agriculture needs to expand even more. How will we do that? At the same time as we use that water, we are also degrading its quality, causing pollution. We now have 400 dead zones, oceanic dead zones around the world, in part due to agricultural runoff. And agriculture is our #1 environmental offender often. It's our #1 contributor to climate change, contributing about 30 to 35% of emissions from tropical deforestation, and also methane emissions from livestock production and from rice agriculture, and then nitrous oxides from the use of synthetic nitrogen fertilizers. So these are just some of the contributors. And agriculture is our #1 offender as well for biodiversity loss. Agriculture has already converted about 40% of natural habitats from former natural habitats, and so that's a huge impact on biodiversity. But one of the impacts today is that new agricultural expansion is happening in the tropical forests and often attacking the primary tropical forests, which are the richest areas for terrestrial biodiversity. So we have all those environmental issues, and at the same time we have to think about what's happening in the future. Of course, we have population growth, and we also have a more prosperous population that is desiring to eat more and more meat and other luxury products. And as a result of this, various projections have suggested that by 2050, we will actually need to double the amount of food that we produce in order to meet the population needs and the consumption demands. But this is a really important point. The question is often asked, how will we double food production by 2050 to feed the world, but without destroying it in the process? We're already at the limits of sustainability. We see that. How could we possibly double food production? The important point is that doubling food needs is a prediction. It's not a prescription. It is not a policy goal. Yet many international and government documents have transformed this doubling prediction to a policy goal. And I'll be going into this in more detail in the first half of this talk. So what is the prediction based on? The assumptions include, first of all, that population will increase to 9 to 10 billion. Second, that consumption patterns will continue to change with increased affluence, as we have seen them doing. And finally, that food waste will continue at the level it is currently, which is 30 to 40%. And it is certainly reasonable to make these predictions based on business as usual. But in theory, each of these can be altered. And so I want to talk about that in the first half of the talk. It's also important to think when we talk about feeding the world, this concept of feeding the world. There's no such thing as a global stomach. And there's also no central authority that manages food production and makes decision on a global scale about how we should produce food. So the concept of feeding the world is kind of strange in that sense. And further, as we know, we already produce enough food to feed the world, but yet we do not feed the world. The world is not being fed. There are many hungry people. So this leads me to suggest that the question needs to be reframed. And we could reframe it as, how do we create a resilient and sustainable food system that meets human needs? So first, let me start by offering some sort of working definition of what a resilient and sustainable food system might be. So here's my working definition. All people have access to sufficient, nutritionally adequate food or the means to produce it. And food is produced and distributed sustainably and equitably. The system is resilient to environmental and social shocks. So if that was our goal, instead of doubling food to meet some predicted needs, then what would it take to create this resilient and sustainable food system? So I'm going to divide my talk into two parts. And the first part is about working towards alternative futures that would reduce these future food needs, and thus the environmental and social stressors that would accompany trying to produce more food than we already are. So I'll talk about how we could achieve smaller population size, how we could reduce meat and dairy consumption, and how we could reduce food waste. And then I want to talk about shifting perspective from this notion of a sort of central authority feeding the world to people feeding themselves. So thinking about moving from food aid towards a food sovereignty framing, moving from industrial towards agroecological and diversified farming systems, and then moving from corporate control towards democratically determined food systems. So this is the roadmap for my talk. I will go fairly quickly through the first part, and then linger a lot on the second part, because that's really where my own scholarship is. So let's start with talking about alternative futures and with population. This is just a critical component of the whole picture of sustainability. So this is a typical population curve that you'll see. Of course, there's been really, really rapid population growth since 1960. Just about every decade, we add about 12 billion or so people to the planet. I'm sorry, did I say 12 billion? 1 billion people to the planet every decade. I'm bad with numbers, so we see that already. And the idea is that around 2050 or so, we should be leveling off at around 9 billion people. And that's the standard population projection that is put into these kinds of models that talk about the need to double food production by 2050. But this is just a model. And as my colleague Malcolm Potts is fond of saying, this is not fixed, this is variable. It depends on what happens. And if we look at some different country situations, we can see that there can be lots of different types of scenarios. So a country's population size is very much determined by the total fertility rate of women. So how many children each woman has in her lifetime. And this shows for the United States how total fertility rates have changed over a very long period. Over about 100 years, they went from about 7 children per woman over her lifetime to what it is today, about 2. But this can happen, and so this transition happened slowly, and is typical of what we call the demographic transition, that over time, as people become more affluent, more educated, and also have the ability to control family size, then they do control family size, and family size diminishes. But let's take a look at Bangladesh, a very different country, and they also had a very, very rapid decline in total fertility rate, but over a much shorter period, just 20 years. So how did this happen? This is not a country that experienced a huge increase in wealth. It's still a very poor country. But there, what happened is that the government recognized that really the key to economic development, to economic prosperity, would be to reduce household family sizes and to reduce their overall population. And so what they did is to really make it a huge priority to make family planning accessible and make information about family planning available. So they created family planning centers, and most importantly, they went out to their population, many of whom were rural and isolated, and brought family planning information and materials to them. So I'm going to show a short film clip